Hello everyone, this is Adish. I'm a grade 10 student from Mumbai. So today's problem is reverse coding. The difficulty level of this problem is easy and you only need to know how to represent a number in base 2 to understand my solution. So before I explain the solution, I encourage you to pause the video now and to try to solve this problem on your own. And now I'll be explaining the solution. So the hardest part in this problem is figuring out what the problem itself is, because in this problem we are basically just given an integers and we just need to find out the answer. They have not told us what the answer will be. So let's first try to make a table in which we say for each number what was the answer which came. So for the number 7, the answer which came was 3. For the number 10, the output would be 1. For number 29, output would be 3. For number 15, output would be 4, and so on. For 16, it would be 1, and for 445, it would be 4. So now, since these numbers are very small and these numbers seem very random, a good idea for such kind of problems is to look at the base 2 representation of these numbers. So I wrote down the base 2 representations, and these are the base 2 representations. And now we need to try to find a pattern. So we know that if we have a number in base 2 which is 111, then we get 3 as the output. If the number in base 2 is 10102, then we get 1 as the output. If the number, so 3 is not equal to this, 7 is equal to this, but basically, so 111 in base 3 will give us 3, 10101 in base 2 will give us 1, 29, which is 11101 will give us 3, and 15, which is 111 in base 2, 4 times 1 in base 2 will give us 4. 16, which is 1 followed by 4 zeros, will in base 2 will give us 1. And the last thing is 445, which is 110, 4 times 1, 0, 1, 2 will give us 4. And now we need to try to find a pattern from the base 2 representation to the output. So notice that whenever the number has all ones, then the answer is just the number of ones. So both 3 and 4 is correct. When the number has some gaps in between the ones and the zeros, like for instance over here, the answer is just the number of consecutive ones. So the answer is just 1. And over here the number of consecutive ones is 3 and 1. So we take the max of those two. So that's why the answer will be 3. And for the next example as well, the answer is 1, which is the number of consecutive ones. And for the last example, the number of max consecutive ones is 4. And there's no easy way to find out how this is true. You just have to use these 7 examples. So that's why this problem was very hard. And now to find out the max number of consecutive ones in the base 2 representation, we can first find the base 2 representation using a simple loop. So I'll show you how we can do that in the code. So first, after we have got this base 2 representation, we can keep track of two variables, cur, which represents the number of current consecutive zeros, and answer, which represents the max of cur over all possibilities. So whenever we have, so if you are iterating over the digits in the array, if the digit is 1, then this means that the current will increase. Otherwise, we'll update answer to be the max of answer comma cur, because the reason why we do this over here is because after this we are setting cur to be 0. And in the end, after the whole loop is done, so after the whole loop, we'll just update answers max answer comma cur, and we'll just print the answer. And this works because we are obviously updating the maximum number of, we are storing how many current number of consecutive ones are there, and we are updating answer to be the maximum of the number of consecutive ones across all possibilities. That's why this code works. And now I'll just show you the code. So in the code for C++, I'll be showing Python in a bit. So in C++, while n is not -1, we store the digits in this vector. So to compute the base 2 representation, we just add n percentage 2 each time, n mod 2, and we reverse the vector because we are accumulating the digits in reverse order. So from backwards, so we are taking the last digit first because n percentage 2 gives us the last digit, and then we divide n by 2. That's why it's in the reverse order. That's why we reverse this list. Then we take len to be the length of the list, and we update count and answer. So if digits of I is 1, we increase count by 1. Otherwise, we set answer to be the maximum answer and count, and we set count to be 0. Then we update after the loop is done, since count may be greater than 0. That's why we update answer to be the max of answer comma count, and then we print answer. And before, like after the loop gets done, we take in the value of n. And the Python code for this problem would be, while true, we take in n. If n is minus 1, we break. Otherwise, we set count to be 0. And so while n is greater than 0, if n is divisible by 2, we increase count by 1. Otherwise, we add count to the array A and print the max of the array A, because so this user is basically storing all the count values in the array A, and then they are setting count to be 0. And notice that they are processing the so it does not matter whether you process the digits in reverse order or in the same order. They are processing the digits in the reverse order, but the quantity, which is the maximum number of consecutive ones, will be the same whether you consider the consecutive ones from left to right or from right to left. It will be the same. That's why it doesn't matter whether you're processing the digits in the reverse order in the same order, and hence this code works. Both these code works. And now I'll just submit this code to see that it gets accepted. So as you could see, my code got accepted. I'd only made a small mistake of using PB instead of pushback, but it got accepted. So I hope you like this problem and my solution. If you had any doubts, do leave them in the comments down below. And if you like this video, don't forget to give it a thumbs up.